So, how do you tell a lump of coal from a snowball? You might think this is kind of obvious. The lump of coal, among other things, there's differences in texture and so on, but a lump of coal is black. A snowball is bright white. Because your eye can tell the difference in the intensity of light, it should be easy. The black lump of coal causes less neural firings, less firing in response to light, than a white lump of snow. But it turns out this can't be right. There's more to perceiving the brightness of an object than the amount of light that hits it. Rather, we're sensitive to the context in which the object is in. And there's all sorts of demonstrations of it. Here's my favorite. So look at these two squares here, the ones with the arrows pointed at them. And you might think one of them, the one on the left, looks light, and the one on the right looks dark. And that's true. And under neutral circumstances, in fact, they would be light and dark. But here's the thing. They're really the same color on the screen. What happens is the one on the left is in shadow. And so since shadows make surfaces darker, your brain compensates and lights it up. Since lights make things brighter, your mind compensates and darkens it. And so, just to prove this to you, what if you took away all of the external cues? So let's start taking things away, and you will see they're actually the same color. This bias in construing the color of things comes naturally to us. If I walk around the stage and all of a sudden I fall into shadow, you don't scream, "Oh my gosh, Professor Bloom is changing color. How remarkable." I don't change color at all to you. Rather, although I might look less light when I step into shadow, your brain automatically compensates for this. And it's these unconscious acts of compensation that cause us to see and understand the world. In particular, in the case we're looking at, there's a simple assumption. Shadows make surfaces darker. And so, if a surface is in shadow, we would assume that it's lighter than it looks, and we actually see it as lighter.